Hello, in this video I will cover the prokaryotic replication fork and its role in DNA replication. For the most part, DNA is double-stranded and antiparallel. This means that one strand of DNA runs in a 5' to 3' direction and its complementary strand runs in a 3' to 5' direction. The polarity of a DNA molecule, or the 3' and 5' ends of a DNA strand, are important as nucleotides can only be added to the 3' end of a DNA strand. DNA replication occurs at the origin of replication, where double-stranded DNA is separated. From origin, replication forms two replication forks so that DNA replication can occur bidirectionally. Ahead of the replication fork, a protein called gyrase leaves supercoiling in the DNA double strand. Following behind gyrase is helicase, which breaks the hydrogen bonds between DNA strands, separating them. RNA primase then adds an RNA primer to the DNA single strand that allows DNA polymerase III to add new nucleotides to the 3' end of the RNA primer. To stabilize single-stranded DNA prior to the actions of DNA polymerase III, single-stranded binding proteins associate with single-stranded DNA. Of important note is the difference between leading and lagging strands. DNA replication has to be in a 5' to 3' direction. Therefore, when the strand being replicated is in a 3' to 5' direction, only one RNA primer is required, allowing for continuous replication. This continuous replication occurs on the leading strand. When the strand is in a 5' to 3' direction, RNA primers will need to be continuously added, causing discontinuous replication that is characteristic of the lagging strand. The short strands of DNA on the lagging strand are called Okazaki fragments. To better understand how the lagging strand is made into a continuous strand of DNA, it is important to mention two proteins. DNA polymerase I removes and replaces the RNA primers with DNA. When it does this, it leaves a nick in the DNA where a phosphodiester bond is missing. DNA ligase connects Okazaki fragments by catalyzing the formation of a phosphodiester bond. Of final note is that a phosphodiester bond is a bond between a phosphate group and a hydroxyl group.